Hey kids, Smath here. Got another kitchen chemistry lab for you today, another one in our thermochemistry installment. Today we're going to be doing a heat of a reaction or a heat of a solution. Also, it's going to fall into our thermostoichiometry. This one's going to take me a little bit to explain. So here's what we're going to do. We're going to take some of this solid sodium hydroxide, and just so you guys don't think, hey, we're playing with real deal here. Okay, we're going to take some of this sodium hydroxide, solid, put it into water, and we're going to let it dissociate. Don't worry, nothing's going to waste. That stuff is great drain cleaner. Okay, it's going to dissociate. And when it does that, I looked it up. This has a value, a delta H of solution. So when this stuff goes into a solution and splits apart, it gives off 44.2 kilojoules of energy. This is exothermic, so we're going to expect this reaction to get pretty warm. It's going to give off heat. What's giving off the heat? The crystals, as they dissolve, as they dissociate, split apart, break those bonds, they're giving off that amount of energy. So what I'm going to do is I'm going to get 4 grams of that. And if I put 4 grams of that into water and let it dissolve, I should get off 44.2 kilojoules. Okay? Now, 4 grams isn't per mole. See, that's the thing we got to remember is this number 44.2 is per 1 mole of this. So I'm not going to use a mole of chemicals because that would be a little bit wasty. Instead, I'm going to use 4 grams. And 4 grams just happens to be, not by accident, a tenth of a mole. So if I get a tenth of a mole, because the molar mass of this is 40 grams per mole. I just got that off the periodic table, okay? So 4 grams, its molar mass is 1 mole per 40 grams. I got a tenth of a mole, a tenth of 44.2 kilojoules should be releasing 4.42 kilojoules in my coffee cup calorimeter. Okay, we use styrofoam cups. They're great insulators here. Okay, now where's the experiment part of this? Well, if this reaction does indeed release this much energy, then we should be able to do an MC delta T. Do a calorimetry experiment. We know the mass, we know the specific heat, and what we're going to do is measure the temperature change as this solution dissolves. Now, let's talk about the mass for just a minute. Seth, you said we were only using 4 grams. How come you've got 104 grams down here? Well, remember, we are dissolving it in water. So what I'm going to do is I just happen to have for you 100 grams of water measured out, okay? Pretty accurate, bottom of the meniscus, okay? That 100 plus the 4 grams of the sodium hydroxide that I'm going to measure out for you. So let's get this going. One of the things we need is, what's the initial temperature of our water? So I'm going to pour our water into our cup. Get all of that. Stir, stir, stir. Always give it a good stir. Let's find out what that initial is. Pretty warm day and water. Okay, I got 25.1 degrees. Stay. That's going to be my initial temperature. And the final temperature is going to be after I've added in my sodium hydroxide. So I need to measure out a little bit more. 399. Okay. 399. Give me 4, okay? So now I'm going to get rid of this spoon so I don't eat off of it. I'm going to take my 4 grams of sodium hydroxide. I'm going to put it into my water and I'm going to stir. Okay, give it a little swirl. Get that good and dissolved. Watching the temperature go up. 30, 31.3, 33, 34. This is getting hot. Ooh, doggy. 35, 35.1, 35.2, 35. And we're slowing down now. 35.2 is the highest temperature we reached. So that was when all the energy was transferred from that sodium hydroxide. And we're definitely going down now. 35.1, on and on. Okay, I'm going to put this over in the sink for safekeeping so I don't spill it. Give my thermometer a real quick rinse off. Give my hands a real quick rinse off. Put that there. That there. Okay, so what does this mean? Our final temperature, 35.2 degrees. So what should happen is if we calculate this energy, we should be able to compare the energy from the experimentally determined value that we put it into solution and compare that to the theoretical value that we looked up. Now, we've done a lot of paper, pencil, take a picture, submit it. This one I think is going to be a video submission. I'm going to try to get this one going on Flipgrid so that you guys can submit a video to me explaining what went on here. I gave you my explanation. Time for you to give me your explanation. I'm Smath. This was Heat of Solution. I'll be looking for you in the Zoom rooms.